In this video, we are going to look at everything that you need to know for Cambridge AS Level Mathematics 9709, Probability and Statistics 1, Normal Distribution. Let's start with the basics. When working with normal distribution, we can say that X is normally distributed, and in the bracket we have mu, the mean, and sigma squared, which is the variance. For normal distribution, we use the formula Z is equal to X minus mu over sigma. Here, Z is the number of standard deviations, X is the given value, mu is the mean, and sigma is the standard deviation. You can use the value of Z and the normal distribution table to find the respective probabilities. First, we find the first two digits of Z in the first column. Then we use the top row to find the third digit. So let's look at an example. This symbol up here is phi, and it simply means the probability. You can use the symbol if you want to, but you don't have to. You will not lose marks in your exam if you don't use it. You can even write probability if you want to. The question says find the probability of Z if Z is equal to 1,26. So we can take our normal distribution table. The first two digits are 1,2. So we use the first column, we go down to 1,2. The next digit is 6. So in the top row, we go across to 6. Move down to the row we found, and we see the probability is 0,8962. When finding probabilities, always round off to 3 significant figures. So I can say the probability of Z is equal to 0,896. Let's do another example. Find the probability if Z is equal to 0,451. Let's take our table. We start with 0,4. That sits over here. Then we have 5. So our probability 0,6736. I'm going to write this up here. 0,6736. But we have to account for this 1. So we look at the column on the far right side. We have 1. Go down to our row, which means we need to add 4. It is a single digit, so we add it to the last digit in our probability over here. So in other words, I'm actually adding 0,0004. Add these together and I get 0,6740. Leave your answer to 3 significant figures. So in this case, probability of Z is equal to 0,674. Let's do one more. Here our Z score is 0,654. So let's take our table. We have 0,6, which sits over here. Then we need a 5. Go down to probability, 0,7422. 0,7422. The last digit in Z is 4. So we go to the far right column. Let's find 4. Go down to our row. And we see we need to add 13. So over here, we add 1, 3. And this becomes 0,7435. But we leave our answer to 3 significant figures, which means here we need to round up. And we see the probability of Z is equal to 0,744. Now I'd like to look at negative z-scores. The normal distribution table only accommodates positive values of z. So when z is negative, we make it positive and we say 1 minus the probability of a positive z-score. Let's look at an example. Find the probability of z if z is equal to negative 1,32. So I can say probability of negative 1,32 is equal to 1 minus probability that z is positive 1,32. Now I can use my distribution table. I have 1,3, find my 2, and I get 0,9066. Keep all 4 digits. So now I can say that this is equal to 1 minus 0,9066. Take my calculator. 1 minus 0,9066 is equal to 0,0934. 0,0934. This is the probability that z is negative 1,32. Let's do another one. Find the probability if z is equal to negative 0,846. So I can say the probability of negative 0,846 is going to be equal to 1 minus the probability that z is positive 0,846. Now I can take my table. I have 0,8, so let's start there. 0,84 falls up here, and I get 0,7995. Let's write this over here. 0,7995. But z has a final digit of 6. Go to the far right column. I have 6. Move down, and I see that I need to add 16. Let's say plus 16. And I get 5 and 6 is 1. Carry the 1, 9 and 10 becomes 11. Carry the 1, this becomes 0 and 8. And I get 0,8011. Let's go back here. Now I can say this is equal to 1 minus 0,8011. Take my calculator. 1 minus 0,8011 is equal to 0,1989. Round off to 3 significant figures, and I get an answer of 0,199. Now I'd like to look at how we find probabilities using normal distribution. Let's start with the probability that x is smaller than a given value. A normal distribution curve looks like a bell curve. The probability is the area under the curve. So the total area under the curve will always be 1. This does not matter in an exam. They will never ask you to find the area under a curve or anything to do with area. But what is important is that the probability we get from a z-score is always the probability that x is smaller than a given value. So in this case, let's say that our x value is here. Our probability will be the area that lies to the left of x. Let's look at an example. The heights of adult men are normally distributed with mean 174 meters and standard deviation 7 meters. Determine the probability that a randomly selected man is shorter than 185 meters. So here, we're being asked to find the probability that x is smaller than 185. When working with normal distribution, we use the formula z is equal to x minus mu over sigma. The question tells us that the mean is 174 meters. This is our value for mu. So let's make a note of this. Mu is equal to 174. The standard deviation is 7. So sigma is equal to 7. And we know that our x value is 185. So now I can say that z is equal to 185 minus mu, 174, all over sigma, which is 7. Take my calculator. 185 minus 174 divided by 7 is equal to 15714. We use z-scores to 3 decimal places. So I can say that z is equal to 1,571. Now I need to find the actual probability. So I can take my distribution table. Z is 1,5. So I'm going to use this column over here. 1,57. So move across to 7. And I get 0,9418. 0,9418. But we have an additional 1. So add 1. And I get 0,9419. But again, we round off to 3 significant figures. I'm going to go back here, and I can say probability of z is equal to 0,942. And this is my answer. Now let's look at the probability that x is greater than a given value. This method of probability does not allow us to find the probability that x is greater than a value, but we know that the total area under a curve is 1, and we can use our z-score to find the probability that something is smaller than that value. So if this is our normal distribution curve, here's x. To find the probability greater than x, we simply say 1 minus the probability that it is smaller than x. Let's look at an example. A group of statistics students are arguing over the length of a movie they've just seen. The data is normally distributed with mean 95 minutes and standard deviation of 4 minutes. Jack believes the movie was longer than 97 minutes. What is the probability that Jack is correct? We are looking at that the movie is longer than 97 minutes. So we want to find the probability that x is greater than 97. We are working with normal distribution, so we're going to use the formula z is equal to x minus mu over standard deviation sigma. The question tells us that the mean mu is 95 minutes. So mu is 95. Standard deviation is 4 minutes. So sigma is equal to 4. The first thing we need to do is input our values into the formula. So I can say z is equal to x 97 minus mu 95 over sigma, which is 4. 97 minus 95 is 2, so I get 2 over 4, which means that z is 0,5. Now I can go to my distribution table, 0,5, and I get 0,6915. Probability is equal to 0,6915. But this probability is the probability that x is smaller than 97. So to find the probability that x is greater, I can say the probability that x is greater than 97 is equal to 1 minus 0,6915. Take my calculator. 1 minus 0,6915 is equal to 0,3085. Round off to 3 significant figures, and I see that this is equal to 0,309. Now let's look at how we find the probability that x lies between two values. We know that the z-score from a normal distribution only gives us the probability that x is smaller than a given value. So when x lies between two values, we find the probability that x is smaller than the greater value, and then we subtract the probability that x is smaller than the smaller value. So let's look at an example. The weights of packets of sweets are normally distributed with a mean of 60 grams and a standard deviation of 5 grams. Determine the probability that a randomly chosen packet weighs between 63 and 68 grams. So we need to find the probability that x is greater than 63 but smaller than 68. We're going to use our formula. Z is equal to x minus mu over standard deviation. The question tells us that our mean mu is 60 grams. So up here I'm going to say that mu is 60. And our standard deviation, sigma, is 5. So sigma is equal to 5. Start with a larger value, 68. And we substitute this into x. So I can say that z is equal to 68 minus mu, 60, over 5. Take my calculator. 68 minus 60 divided by 5 is equal to 1,6. So z is equal to 1,6. Now I can take my distribution table. Z is 1,6. When z only has 2 digits, we use the first probability, which in this case 0,9452. For now, keep all 4 digits. So I can say the probability is equal to 0,9452. This is the probability that x is smaller than 68. But to find the probability that x lies between 63 and 68, we need to subtract the probability that x is smaller than 63. And all we need to do now is substitute 63 into our formula. So I can say that z is equal to 63 minus mu, 60, over standard deviation, which is 5. Take my calculator. 63 minus 60 over 5 is equal to 0,6. So z is equal to 0,6. Take my distribution table. I have 0,6 over here, and the probability 0,7257. Probability is equal to 0,7257. To find the probability that x is greater than 63 but smaller than 68, all I have to do now is subtract the smaller probability from the larger one. So I can take my calculator. I can say 0,9452 minus 0,7257 is equal to 0,2195. Probability is equal to 0,2195. Round off to 3 significant figures, and I get 0,2195 2, 2, 0. Now I'd like to look at how we find z-scores from given probabilities. You can find the probability on the normal distribution table, then use the first column and the top row to determine the z-score. Let's look at an example. Determine z if the probability of z is 0,9744. Let's take our table, and down here we have our probability 0,9744. Let's start with the row. It's row 1,9 and column 5. So we can see that z is equal to 1,95. If the probability is not in the table, find the nearest probability that is smaller than the one given to you, and then use the columns on the far right to add additional digits. As an example, let's find z when the probability is 0,6030. Let's take our table. We have 0,6 up here, and it should lie somewhere over here. Use the smaller value, which in this case is 0,6026. It's in the row 0,2, so I can say 0,2, column 6. I can put 0,26, but I don't want 0,6026. I want 0,6030. So I need to add 4 to this value. I can go to my far column. Here I have 4, which means I add 1 to my z-score, and I get 0,261. This is the value of z. Now I'd like to look at probabilities smaller than 0,5. From the normal distribution table, there are 2 things that we know. 1, it only works with positive z-scores. And 2, it only considers probabilities greater than 0,5. Positive z-scores will always give you a probability greater than 0,5. And negative z-scores will always give you a probability smaller than 0,5. So it stands to reason that if you have a probability smaller than 0,5, then z has to be negative. We know that to find the probability of a negative z-score, we say 1 minus the probability the score is positive. So to find the z-score of a probability smaller than 0,5, we use 1 minus the given probability, and then we make our z-score negative. You do not need to write this equation in your exam, just keep it in mind. So let's look at an example. Determine z if the probability of z is 0,3594. Probability is smaller than 0,5, so we know that z will be negative. To find a probability that I know will be in our distribution table, I say 1 minus 0,3594. Take my calculator. 1 minus 0,3594 is equal to 0,6406. 0,6406. This is the probability I'm looking for in my table. Starts with 6, and I can see the probability lies over here. It's in column 0,3. So I can say 0,3, column 6, 0,36. So z is equal to negative 0,36. Let's do another one. Determine z if the probability is 0,05. Let's start by subtracting this from 1. 1 minus 0,05 is equal to, take my calculator, 1 minus 0,05 is equal to 0,95. 0.95. Now I can move on to my distribution table. I need 0.950, and it's going to sit somewhere between these two values. Always use the smaller value. This lies in row 1,6. So I can say 1,6. Column 4, 1,64. But I want 0.95, which means I need to add 5. So if I move to the far right column, to add 5, I need to add 5 to my z-score. So now I can see that z is equal to negative 1,645. If you can do this, you can do anything relating to normal distribution. Hopefully this is relatively simple to understand, but it becomes tricky when you have a probability greater than x that is also greater than 0.5. Just remember to tackle these types of questions in stages. Now I'd like to look at how we go about finding unknown values. To find an unknown value, such as the standard deviation sigma, the mean mu, or the given value x, we substitute the known values into the formula for the z-score and solve. Just remember that if you have two unknown values to find, use simultaneous equations. Let's look at an example. The weights of small bags of pasta produced by the company are normally distributed, with mean 0.75 kilograms and standard deviation sigma kilograms. It is found that 68% of these small bags have weight less than 0.9 kilograms. Find the value of sigma. So let's start with the formula. Z is equal to x minus mu over sigma. Sigma, the standard deviation, that is the value we need to find. So let's see what we know. The question tells us that the mean is 0.75. So up here, I'm going to make a note that mu is equal to 0.75. It is found that 68% of these bags weigh less than 0.9. 0.9 is our x value. So I can say x is equal to 0.9. 68% is our probability. So we can write this as a decimal. So I can say the probability of z is equal to 0.68. And I can use my distribution table to find the value of z. I need 0.68, and the closest I can find is 0.6772. Lies in the row of 0.4. I can say 0.4. Column is 6. But I want something as close to 0.68 as I can. So I need to add 28 to this value. Move across to the far column. I don't have 28. So in a case like this, find the closest value, 29. Let's go up to the top, which means I need to add 8 to my z-score. Now I can go back over here, and I can say that z is equal to 0.468. Now I've found values for the other three variables in the formula. So let's substitute. I can say 0.468 is equal to x 0.9 minus mu 0.75 all over sigma. To solve for sigma, I need it to be out of the denominator of the fraction. So let's multiply both sides by sigma. And on the left, I'm going to get sigma is equal to, I'm going to divide by my x score. So on the right, I'm going to have 0.9 minus 0.75 over 0.468. Take my calculator. 0.9 minus 0.75 over 0,468 is equal to 0,3205 and so on. Always round off to 3 significant figures. And I can see that sigma is equal to 0,321. Now I'd like to move on to the z-score and the standard deviation. The z-score is the number of standard deviations that a value is away from the mean. If we are considering values a certain number of standard deviations away, these values lie on either side of the mean. So we need to consider both the positive and negative values of z. Remember that a normal distribution takes on the shape of a bell curve, and the mean, mu, always lies in the middle. If we have values that are a set standard deviation away, they will lie on this side, where z is positive, and they will lie on this side as well, where z is negative. Let's look at an example. The mass of grapes sold per day by a large shop can be modeled by normal distribution with mean 28 kilos. On 10% of days, less than 16 kilograms of grapes are sold. In a random sample of 365 days, on how many days would you expect the mass of grapes to be sold to be within 1,3 standard deviations of the mean? Let's draw a quick graph. There's our bell curve. There's our mean. And we are looking at values within 1,3 standard deviations. So we have positive 1,3 on the right and negative 1,3 on the left. This means that we need to consider z value of 1,3 and a z value of negative 1,3. When we have our z values, we don't need to use the formula. All we need to do now is find the respective probabilities. So let's look at the normal distribution table. A z-score of 1,3 gives me a probability of 0,9032. I can say the probability of z is equal to 0,9032. Now I need to find the probability that z is negative 1,3. But because it's negative, I have to subtract the probability from 1. So I can say the probability that z is negative 1,3 is equal to 1 minus probability that z is positive 1,3. I already know the probability that z is 1,3. So I can say 1 minus 0,9032. Take my calculator. 1 minus 0,9032 is equal to 0,0968. 0,0968. Now let's look at our bell curve. The probability that z is smaller than 1,3 is this area over here. But we want the area inside. So all we need to do is subtract the area to the left of negative 1,3. So now I can subtract my smaller value from my larger one. And I can say 0,9032 minus 0,0968 is equal to 0,8064 equal to 0,8064. But the question is not asking us for probability. It's asking us for the number of days we would expect to see. So all we have to do now is multiply this by the total number of days, 365. Take my calculator, multiply this by 365 is equal to 294,3, but it's a full day, so we round off to the nearest whole number, and we get 294 days. Finally, I'd like to look at approximation. Normal distribution considers continuous data, but binomial distribution considers discrete data. Approximation allows us to use normal distribution on discrete data. Binomial distribution gives us the following information: N, the total number of trials conducted; P, the probability a trial is successful; and Q, the probability a trial is not successful. When working with binomial distribution, we use the following formula. When using normal distribution, we use this formula. But we use the data from binomial distribution for the mean and the standard deviation. So to find mu, we multiply n and p. And to find the standard deviation sigma, we say npq under a square root. If the square root gives a number with a lot of decimals, we can just leave it as npq under a square root. When using approximation, we have to make a small change to the given value of x. If we are looking for the probability that x is greater than something, we add 0,5 to x. But if we are looking for the probability that x is smaller, then we subtract 0,5 from x. In real-life situations, you cannot always use approximation on binomial and normal distribution, but in your exam you can, so don't worry about this. But if you are asked to justify approximation, simply show that NP is greater than 5 and that NPQ is greater than 5. Now let's look at some examples. In a large college, 32% of the students have blue eyes. A random sample of 80 students is chosen. Use an approximation to find the probability that fewer than 20 of these students have blue eyes. Let's start with our N, P, and Q values. 32% of these students have blue eyes. This is our probability, so we can write this as a decimal. At P is equal to 0,32. Q is the complement, 1 minus 0,32, so Q is equal to 0,68. We're looking at a sample of 80 students, so N is equal to 80. Now, for normal distribution, we're going to say Z is equal to X minus mu over standard deviation. To find mu, we multiply N and P. So I can say that mu is going to be equal to 80 multiplied by 0,32. Take my calculator. 80 multiplied by 0,32 is equal to 25,6. 25,6. Now I can find the standard deviation sigma. Sigma is equal to NPQ under a square root. I already have the value of NP, so let's multiply this by Q. Multiplied by 0,68 is equal to 17,408. If I square root this, I'm going to get a lot more decimals. So to make it easier, I'm going to say that sigma is equal to 17,408 under a square root. Now all I need is my x value. The question is asking us to find the probability that fewer than 20. So we are looking for the probability that x is smaller than 20. So I need to subtract 0,5 from 20, and I see that x is equal to 19,5. And now I can put these values into my formula. I can say z is equal to x 19,5 minus mu 25,6 over standard deviation 17,408 under a square root. Now I can take my calculator. Let's create a fraction. 19,5 minus 25,6 over the square root of 17,408 is equal to negative 1,462, and so on. For a z-score, we round off to 3 decimal places. So I can say that z is equal to negative 1,462. I cannot use a negative z-score. So to find the probability, I'm going to say probability is equal to 1 minus positive, or the probability of positive 1,462. Let's find this value in our table. Z is 1,4. We're going to use this row. 1,46, this column over here. 0,9279. But my z-score is 462. So I need to add 2 to z, which means I add 3 to my score. Let's add 3, and I get 0,9282. Let's go back over here, and I can say the probability is equal to 1 minus 0,9282. Take my calculator. 1 minus 0,9282 is equal to 0,0718. Probability is equal to 0,0718. That is my answer. Let's do one more. A factory produces a certain type of electrical component. It is known that 15% of these components are faulty. A random sample of 200 components is chosen. Use an approximation to find the probability that more than 40 of these components are faulty. Once again, let's start with our N, P, and Q values. 15% are faulty. This is our P value. So the decimal, we can say P is equal to 0,15. Q is the complement. So here Q will be equal to 0,85. The sample consists of 200 components. So N is equal to 200. We are working with normal distribution, so we need to use the formula Z is equal to X minus mu over sigma. To find mu, we multiply N and P. We can say mu is equal to, take my calculator, 200 multiplied by 0.15 is equal to 30. So my mean is 30. To find the standard deviation sigma, I multiply N, P, and Q. I already have a value for N and P. So let's multiply 30 by Q. 0,85 is equal to 25,5. So for sigma, I can say 25,5 under a square root. We are looking for the probability that X is more than 40. So to find our X value, we need to add 0,5 to 40. So X is equal to 40,5. Now I can put these values into my formula. I can say Z is equal to 40,5 minus mu, 30, over standard deviation, 25,5 under a square root. take my calculator. Let's create a fraction. 40,5 minus 30 over the square root of 25,5 is equal to 2,0793 and so on. For a z-score, always round off to 3 decimal places. So I can say that z is equal to 2,079. Now I can go to my table. I have 2,0, 2,07 gives me 0,9808, 0,9808. But our z-score is 2,079. So to account for the 9, go to the file column. Here's 9. So I add 4 to my score. Add 4, and I get 0,9812. This is my probability. So I can say the probability is equal to 0,9812. But this is the probability that x is smaller than 40. And we want the probability that x is greater than 40. So all we need to do now is subtract this from 1. I can say 1 minus 0,9812. Put this into my calculator. 1 minus 0,9812 is equal to 0,0188. So my final answer is 0,0188.